everyone. Thank you for coming. It's really nice to be here and giving a talk, to have this chance. My name is Andrey, and personally, I like practice-related, easy to apply approaches the most. Such approaches allow you to get better code with minimal effort. And today I'm going to talk about Elixir structs and their place in your project. But first, let me continue to introduce myself. Yeah, I'm from Russia, but currently I work and live in Estonia, in Tallinn. I studied as a .NET developer some time ago, and after several years being .NET developer, I got tired of career full of enterprise stuff, and I switched to Ruby and then to Elixir. I don't want to bother you because it's pretty common switch. I've been writing Elixir codes on daily basis for more than 2 years, and occasionally I write articles. You can find them in Medium. I created a few open source libraries, Exop Express, for example. And the approach I'm going to share with you, I use almost in every project. Let's return to it. Elixir offers us a bunch of container collection types. There are lists, tuple, keywords, lift maps, structs. I have highlighted structs here because they are special. Regarding the official documentation, structs are extensions built on top of maps that provide compile time checks and default values. And checks highlighted here because this is some kind of special behavior. And I'd like to provide my personal definition for struct as a bridge to the rest of the talk. Structs are data structures built on top of maps that conform predefined public contract. Why it is important to think about contract when we are thinking about struct or consider to use it? Contract is something that we expect to get. Contract defines rules between parts of project involved in some interaction, collaboration. Defining a struct, we describe and set some expectations. If two parts of a project conform the contract, let's say they use structs in their communication, we can be confident in data that those parts share between each other. On another hand, maps don't define any contract. Their contract exists here and now when we use pattern matching or something like this. This is why code based on structs is easier to maintain, read, and update in the future. Let's consider a basic example. On the left side, I show you how structs and maps are similar. In this case, in terms of pattern matching. So you define some map, pattern match. Even if map has more field keys and fields than left side, it will be okay. But let's take a look on the right side. What's the actual difference? When we take a map into the function and looking into this code, we cannot see with confidence what else this map contains, how this particular function and this map are connected. And see how just taking a look into this function's definition with pattern matching on a struct, we know how they linked. At least we have, at least they have a name behind this data. And it's not only about a name or a bunch of fields defined in struct. triangle is model itself. And in this case, we know where we should go to see and where we can get more information about the data behind this name. Why can't we have a model with, as I said, a structure itself, not just a bunch of fields? It's a module itself, and why can't we have a module with data definition and some additional behavior or responsibilities in it? This will make a structure a self-consistent, standalone unit, a brick in your project, in your project's domain. A structure model can have a number of functions to deal with defining data. This module can provide documentation, specifications, and all the information you need later, and you need to know about the data behind the structure contract. Let me show an example of such structure model. We define it in module, we define it fields this structure should have. Also, we provided a constructor to generate triangles from incoming parameters. I have omitted all these public or private functions. It depends on your API of this module, just in sake of example. But see how this particular module could have functions to deal with the data it describes. But someone could have objections. There are a lot of code now, and bringing structures into code will force me to create more files, write more code. Yes, but proper responsibility allocation, we get with proper responsibility allocation, we will get more organized code, which in general and with structure modules in particular, much simpler to test and maintain. Now let's see how can we utilize Ecto to write less code by ourselves, and we can reduce the number of lines of code that we have to write in order to validate and handle the data behind struct. We have an opportunity to delegate all the work to Ecto and use its power to construct structures, because Ecto schema is a structure itself. And Ecto has a lot of handy stuff out of the box. Bonuses of these approaches are, well, almost everyone knows how to work with Ecto. So schema declarations is well known. You get arguments casting, type checks, custom types, built-in, a bunch of built-in validations, and ability to implement your own validations for free. Well, out of the box. It's not totally free. And you can construct even more complex and nested structs and apply validations on them, as I said, out of the box. But there is some cost of using an Ecto, and I will provide the information about it a bit later. Now let's consider a more practical example. Consider those two actions in a controller. Let's say our system should create or update some invoices. Now here we can see create and update actions, which are pretty common. We can see such code every day. In order to create or update an invoice, we expect a number of parameters which came to those actions as maps. And we try to validate them firstly with guards, but it's not enough, so we need to go further and validate them in an action body. Then, I don't know, modify those parameters if needed. and handle all these errors in the action itself. Despite this controller is hard to test and update, we might be pretty happy with this solution. It's pretty straightforward, and we continue to work in this way for some time. But later, it could be something like this. This is a mini-map, and from some real project which wasn't refactored yet. We will try to refactor this controller, reorganize code somehow, and of course we have a lot of ways to do it. Let me show you how I do it and how it could be. First of all, we define two structures for request and response. In the roots, we assign request and response modules to each root and action, so we will have those modules with every request to our controller, assign it to a connection structure. Then we create, let's say, request builder. It's a simple plug which takes, with every request, it takes this pair of modules and invokes the constructor on request module. If everything is okay, we assign the structure with data itself to the connection. If something went wrong, we just return an error tuple. In the controller, we define a fallback controller, which will handle all these error tuples, everything which is not a connection itself. And C, we define a request builder in order to invoke this every time, every request. So when it came to an action itself, we already have a request structure and response module. And this structure, by invoking a constructor of this module, we know that this data has been validated, it's full, consistent, and we can trust it. Then simply we do some stuff, we do the actual action, delegate this work to separate module, get some result. If this module return an error tuple, it will be handled by fallback controller. If it's okay, we just take this action result, response module, and set it to a view, which will invoke the constructor on response module and do some stuff with it. It simply converts it to map, for example, and return as JSON. You can experiment and it proves this approach constantly because there are many options how, and you can find the way which is the best for you or for a particular project. Before you ask, such structures usage is not only about incoming HTTP parameters validation. It is more about domain-driven development and breaking a project into independent units. For example, one of my services works in production for more than a year, and I used the same approach there. Briefly, this service is about a delivery. This service takes a schedule, couriers list, delivery info, and searches for the best courier and time for the delivery itself. So the delivery will take a minimum time, and almost all internal communication between parts of this project is based on structures. Day schedule, its columns, a courier and his own schedule, a delivery, everything is data and represented as a structure and structure modules. But there should be a balance while trying to make your struct model more independent. Please do not put all the logic into it because, well, who came from Rails knows this thing about models. So try to keep an eye on the size of your structures modules. Protobuf could be an alternative, but it's not suitable. For the first, it's not suitable for the internal communication. You probably don't want to encode and decode every time you want to pass the data from one module to another. And at the second, not for all HTTP communication. It suits, practically, it suits only when you implement both sides, server and client, or your partner who implements a client has a will to use protobuf as well. You just simply cannot use protobuf only on one side. And I promised to say something about the cost of Ecto utilizing. I've made a benchmark. Plain structure with Ecto schema. The requirements for structure itself were pretty simple. It should atomify given parameters map. For if needed, check required parameters presence, check given parameters types. And obviously the code written by yourself and for this certain case is much faster. You can use the pattern matching within your code in most cases and shouldn't provide universal and common solution. So maybe in super high load, if you're really interested in efficiency, in super high load projects, you should consider plain structures written by yourself. But in most cases, anyway, Ecto is very good choice to go with because 6 microseconds, it's great. Micro. You can see the code of this bench, for example, if something, but that's it, I suppose. Thank you. And it's almost 20 minutes. I have 40 seconds for drink.